Finding the shortest distance from a point to a line. An example application question that uses the mathematics we will learn in this video involves some friends camping out in the woods. Imagine that one of the campers needs emergency help and the friends have called for support. It may be very hard for paramedics to find their specific campsite. If one of the friends, let's call him Bill, can walk to the road, Bill can meet the ambulance and help direct the paramedics to his troubled friend. To get to the highway, Bill wants to travel the shortest distance possible so he can get there as quickly as possible. This is the path Bill wishes to take. If we were to simplify what is going on with the diagram, what we would have is Bill's starting location, shown here by the black dot. The path he walks would be the red line segment, and the highway would be the black line. What we are being asked to find is the length of the red line segment from the black dot to the black line. Obviously, without numbers, we cannot figure out an answer, but of course, in a math test problem, you would be given enough information to figure out the solution. If we had the coordinates of Bill's starting location, let's call that x1, y1, and we knew the coordinates that we want to reach on the highway, let's call that x2, y2, we could use the formula for the length of a line segment to find out the distance from the campsite to the highway. Recall that to find the length of a line segment, you need the two endpoints. Then you can use the distance formula. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. However, if you only have one of the endpoints, you will need to find the location of the other point before you can determine the segment's length. The following demonstration done in Desmos will help us see how we can find that missing endpoint so we can then find the length of the line segment. If we were given the equation of a line and a point not on that line and asked to find the shortest distance from that point to the line, we could try to figure it out by estimating. Here in this diagram, we have the equation y equals 0.5x plus 2.5 representing the red line. The equation could also be written as y equals 1/2 x plus 2.5. Then we have the point, which is labeled point and is blue. The black dot on the red line will help us to estimate the shortest distance from the line to the point. As we move the black dot, we can see that we are getting closer to the best answer. If we were to draw a line from the black dot to the blue dot labeled point, that might help us to better visualize the distance from the black dot to the point. Here we can clearly see that as we're moving closer, that green line is getting smaller. Desmos will also calculate the length of the line so that we can verify our estimate. Here the distance is 7.88 units. Here 3.81 units. 4.43 units. And it appears that at the point 3.28, 4.64, the shortest distance will be discovered. That distance is 2.46 units. As we worked on this example, we were simply estimating, but there is a way to be able to determine the distance that is the shortest distance from a point to a line by using some algebra. Let's look at some more examples and see if you can notice a pattern. What you may have noticed is that the shortest distance from the point to the line occurs when that green line is perpendicular to the red line. We now have the label of slope on our graph, so we can see the slope of the green line. We can compare it to the slope of the red line, which is 0.5 or 1/2. Let's see what happens to the slope 3.42 as we change the length of this line and thus the equation of the line. Here the green line segment is perpendicular to the red line, and we have the distance that is the shortest one. In this example, the red line has a slope of 1. the slope of the green line segment should be -1 over 1. That will give us the shortest distance from the red line to the point. When you're trying to algebraically find the shortest distance of a point to a given line, we can now use information regarding the perpendicular properties of the shortest distance of a line segment to a line. When we look at the red line here, we can see that the equation is y equals -0.33333x plus 8. That value for the slope is the same as -1 over 3. The blue point is at 3, 8, and now we know the slope of the line segment going from the blue point to the red line. It's going to be the negative reciprocal of -1 over 3. Flip -1 over 3 to get 3 over 1, and then multiply by -1 to have the positive value. We get a slope of 3 for the green line. We still don't know the length of this line, however. In order to find the length of the line, we need to have the value of the black point, and that black point occurs when the red line intersects with the green line. So we need to find the point of intersection of these two lines. In order to do this, we need the equation of the green line. We can now find this equation because we have the slope and we have the value of the point. The point is at 3, 8, and the slope is 3. We can substitute these values into the formula for the equation of a line, which is y equals mx plus b, to isolate b and find out what the y-intercept is of the green line. Once we know that, we will have the y-intercept and the slope, which was 3, and we'll have the equation of the green line. We already had the equation of the red line, which was -1 over 3x plus 8. So using substitution or elimination, we can find where these two lines meet. That coordinate point can be used with the blue point, 3, 8, and the distance of a line formula to find the length of the line that is the shortest distance from the blue point to the red line. The Desmos demonstration revealed some key points. The shortest distance from a point to a line occurs when the line segment created by that point to the line is at a 90-degree angle, or we can say the segment is perpendicular to the given line. Therefore, the slopes of the line segment and the given line will be negative reciprocals. Let's look at an example. Given a point at 5, 7, what is the shortest distance from the point to the line, y equals 1 over 5x plus 10? First, we know the line segment slope will be -5 because it is the negative reciprocal to 1 over 5. Next, we can find the line segment's y-intercept by using algebra. Substitute 5, 7 and -5 into the equation y equals mx plus b to get 7 equals -5 times 5 plus b. Then isolate b. 7 equals -25 plus b, so 32 equals b. Then we can use the line segment slope and the y-intercept value we just found to write the equation of the line segment. It is y equals -5x plus 32. Now that we have the equation of the line segment and the equation of the line we are trying to find the shortest distance to, we can use substitution or elimination to find where they intersect. The coordinates where they intersect will be the endpoint of the line segment that is the shortest distance from our original point to our original line. The original line's equation is y equals 1 over 5x plus 10. The line segment's equation is y equals -5x plus 32. Elimination gives 25x equals 5x plus 250, y equals -5x plus 32. When we add those two equations together, we get 26y equals 282, y equals 282 over 26, therefore y equals 141 over 13, or 10.077. Now we can substitute 141 over 13 for y to get x. Y equals -5x plus 32. 141 over 13 equals -5x plus 32. 141 over 13 minus 416 over 13 equals -5x. -275 over 13 equals -5x. Therefore, x equals 55 over 13, or 4.231. With the original segment endpoint coordinates 5, 7, and the newly discovered second segment endpoint coordinates 141 over 13, 55 over 13, we can find the length of the line segment, which is the shortest distance from the original point to the original line. We will begin with the distance formula. In the second line, we substitute in the x and the y values. We continue with algebra rules to get to our conclusion. The distance equals the square root of 2,600 over 169, or 3.922. Let's summarize how to find the shortest distance from a point to a given line, starting with how to find the equation of the line segment. Steps to finding the shortest distance from a point to a line. Find the equation of the line segment. Number 1. First get the slope of the line segment. It will be the negative reciprocal of the perpendicular line slope. Number 2. Substitute the point you were given, x, y, and the slope you just found, m, into the form y equals mx plus b. Then isolate b to find the y-intercept. Number 3. The equation of the line segment will contain the slope, m, and y-intercept, b, that you have just found. Next, find the point of intersection between the line segment's equation and the perpendicular line's equation, the equation you were given. Number 1. Use substitution or elimination to find the coordinates. This x, y value is the unknown end of the line segment. Substitute the two endpoints, the point you were given and the point of intersection, of the line segment into the distance formula to find the length of the line segment. Finally, let's complete one last example. What is the shortest distance from -5, 1 to the line y equals 6x plus 7? First, find the equation of the line segment. First, get the slope of the line segment. It will be the negative reciprocal of the perpendicular line's slope. So the slope, m, equals -1 over 6. Number 2, substitute the point you were given, x, y, and the slope you just found, m, into the form y equals mx plus b. Then isolate b to find the y-intercept. 1 equals -1 over 6 times -5 plus b. Thus, b equals 1 over 6. Number 3. The equation of the line segment will contain the slope m and the y-intercept b that you have just found. Y equals -1 over 6x plus 1 over 6. Find the point of intersection between the line segment's equation and the perpendicular line's equation, the equation you were given. Number 1. Use substitution or elimination to find the coordinates. This xy value was the unknown end of the line segment. 6x plus 7 equals -1 over 6x plus 1 over 6. X equals -41 over 37. Y equals 13 over 37. Finally, substitute the two endpoints, the point you were given and the point of intersection of the line segment into the distance formula to find the length of the line segment. When you do that, you will find that the line segment length equals 3.95 units.